There, now it's 10:30, so let's get started. Welcome everyone to this webinar called Digital Flow of Traffic Regulation and AI-Powered Discrepancy Analysis, and more. We are very happy to see so many people here. I see there's still people coming in. My name is Kristine Bull-Schettolt, and I work as an analyst at the Swedish Transport Administration, and I will be moderating this session today. We have some practical information first. This webinar will be recorded and it will be made available a bit later. And everyone except for the presentators will be muted during the presentations. But when it's time for the Q&As, we will open up the possibility to unmute and also turn on video. And also, as you can see, the chat is also closed. It will open up when we're getting to the Q&As. So you're able to either write your questions in the chat or raise your hand, and then you can ask the question yourself. And we do have lots of time for questions to the program, so we hope that you all are interested and wants to ask questions to our presenters. And if there's any technical questions during the presentations, please email Alva Blomqvist, and her email address is in the invitation email that you got for all the webinars. So here's the agenda that we'll go through today. We will begin with several presentations on the topic of traffic regulations. So we will listen to results from different pilots and projects from Sweden. And first we will begin with a presentation about the meter concept, which is the work being done for a standard for digital traffic regulations. And after that, we will hear more about the Swedish Transport Administration's work on this topic, so what we're doing right now, but also the steps moving forward after the project ends. We will also hear from Universes, who will present their work with AI-powered discrepancy analysis, and also a presentation about the pilots from Stockholm and Gothenburg. So after this long session, we will have a joint Q&A with all the presenters. So there you can write questions to all of them, and please indicate who you're asking your question to. After this Q&A, we will have two more presentations, one by Rise on in-vehicle signage of MCS signs, followed by a presentation on warning for approaching trains. And now I think it's time to get started. So please welcome the first presenter, that is Magnus Gustin from the Swedish Transport Administration. And in this project, he has worked as an IT architect for the pilot sustainable traffic rules. Magnus, please take over control and go ahead. Are you there, Magnus?
Now, can you hear me now?
Yes.
Can see me. Okay, so this first topic is a short study. We have been looking into the meter standard, and I'll change. And the way we produce and distribute digital traffic regulation and what impacts it may have in Sweden. First, we will mention a bit about what meter is as a short background. So meter is an acronym that stands for Management of Electronic Distribution of Surface Transport Rules, abbreviated METR. And it's a standard that is being developed with a goal to standardize how transport agencies can ensure that transport users have trustworthy information regarding rules of the road, so to say. So a meter is a concept and a vision for how stakeholders can cooperate around digital traffic regulations. And it's been developed within a standard committee. It's called in ISO 24315. And The content of the standard as of now, a quick overview here, is there is definitions of actors and their responsibilities. There are some main use cases. There is a description of the information content of a digital traffic regulation, and also functional mechanisms and information flows. And it also points out the need for certain system capabilities, which will be the base for this future, for any future architecture decisions, really. So it's a kind of a base for further work, really. And the three artifacts so far, which we have been studied, is a vision document with some use cases, and another document which is called operational concepts, and the third document is called system of systems, requirements and architecture. This meter standard does not stand for itself, and it's heavily dependent on other more concrete standards like DATEX 2 and the TNITS. In the meter standard, we have there's a definition of different roles and their main responsibilities. And the rule maker is the authorities that will issue the traffic regulation order. And this can be both on different levels, can be national, can be regional, can be municipal. And a short disclaimer here, I will often use the term traffic rule mostly because it's easy to say, but there is also called traffic regulation or traffic regulation order and so on, but it's the same, it's synonyms really. And then we have supporting data providers that can be mostly for dynamic traffic rules. It could be roadwork information, can be sensor data, so on. We have the translator role in meter, a role that translates the incoming the information. And we have the collector that collects data and stores it in some kind of central storage. We have the disseminator, which make the traffic rule data available to customers. We have a role here called installer, and that is the role that installs the traffic rule in the physical environment, but it covers both physical environment as in road signs but also in form of education, so like driving schools and so on is covered in this role. And then we have the service provider on the right side, which is sort of a, yeah, of course, it's a service provider, but it also acts like a middleman towards the end user. And the end user roles can be different, can be vehicle driver assistance systems, can be fleet management systems, can be route planning systems, and different use cases and scenarios. And then below we have something called supporting legal roles. Can be legal bodies, police, courts, etc., that are more indirect involved in this process, like in potential legal processes. So that was actors and main use cases. If we look a bit into the information content of a digital traffic rule, it's rather obvious. It's nothing really that differs from a handwritten traffic rule, but the goal here is to make this standardized and structured. And then we have cases, things like traceability, origin, what kind of publication is it, what law section is it based upon. We have traffic rules with conditions. We have where, like a road name between points, or can be a zone, can be down on different driving lanes, etc. And then we have the when is it applicable, Is it a rule that is always on, or is it just for peak hours, etc.? And then, of course, who is this traffic rule apply to? Is it all vehicles? Is it certain vehicle types? Only some kind of business, taxi, slow driving vehicles, etc.? So there are different, all kinds of different rules, and we have to make this classification standardized to make it work digitally. I think this is classification probably not ready yet, really, and the DATEX2 standard leaves quite open possibilities to express conditions, but these requirements may vary between countries. So for more automation, it will probably be good to standardize most parameters and hopefully to find a common ground, and then maybe complement with some free text information for the edge cases. So there's a way to go here, I think. If we take the next slides, we move into a kind of process slash system kind of slide. I will be use this format a couple of times here. The upper part is the process, and the lower part is the system capabilities we will need to support the process. And if we look at the static traffic rules, the first 2 or 3 parts of the process is mostly covered by something we call preparation systems, which we rely heavily on. They are available on the market, and most authorities will use them. It's a kind of systems that will produce a machine-readable data traffic rule used by municipals, some regions, and of course nationally, Trafikverket, which I represent. And this information is then stored in a central database called STFS, which is managed by Swedish Traffic Agency, Transportstyrelsen in Swedish. For the validation part, there is some validation in STFS, but for this to work, we need a more deep validation. We need to set the traffic rule in context with the road network and its other surrounding traffic rules, really. This is being developed right now by Trafikverket, and it will be described more later in this session. For the dissemination part, now in Sweden, we rely heavily on the NVDB format, which is the National Road Database. And we will start looking into distribution of traffic data within DATEX2, which is connected to the meters standard. And then, of course, use the rightmost process is how to make this available. And that will be through download services or APIs. For instance, we have an open data platform, Trafikverket, which probably will be used to distribute this data to the different service providers. And now I will, okay, I must scroll to the right here. Sorry. If we look, on the other hand, on the dynamic traffic rules, the difference here is with the dynamic traffic rules, we mean traffic rules that can change almost like any time can be due to manual decisions or can be driven by automated sensor data and so on. And this area is something that really we need to develop in Sweden. The process so far has been mostly on the static traffic rules. So we see that we must improve ways to collect data from like road management systems, sensor data, and so on. In most cases, there is an underlying traffic regulation order or some other road management agreement, but the content of that is that it contains some dynamic parameter. Could be related to weather, could be related to the amount of traffic, and so on. We also believe that all these various input sources will probably need to be sent to a central hub where the meter data conversion will take place. So we cannot really require that all kind of input systems will have to adopt to meter and datex2. And then we also think, or know really, that we must extend the scope for the national database. Today, it's just static traffic rules, as I said. Okay, finally, some key concepts and findings in this study. A digital and highly automated system such as meter must be able to provide high quality data. To achieve this, we find some aspects. The quality feedback loop is needed. Even though we have system tools, the actual traffic rule is created by a human being, and that can cause errors. So a feedback loop is needed to detect such incorrect and incomplete information. We will demonstrate something of this later on. We also need to trust the system. So any party that is involved in the creation or transformation of the data must have a certified and trusted authentication, obviously. So nobody can feed false data into the system. In Sweden, we also have a challenge around the location referencing. Today, things are always connected to the National Road Database linear model. But we now see that the master data itself is not necessarily like on a linear model. It can be just coordinates, can be zones, polygons, etc. And that will require some development on our side, at least. And about datex2, it has historically been used only for traffic information, not traffic regulation. So now, as these things merges with the new version of datex2, as you may know, there is a new package, a traffic regulation package in the datex2 standard. So probably we will need to somehow merge or at least coordinate this process on the Trafikverket side. Now I'm talking, as I said, the Swedish perspective, because this has been separate processes up to now, traffic information and traffic regulation. So also, like I said, in Sweden, we have a strong tradition around NVDB, which is the National Road Database, and the model, including tools, producers, and consumers of data. One possible development could be that now when we have international standards that will support this, we could see a movement from this local standard, so to say, to this emerging international standard. And that I believe, at least, it could be good both for service providers and tool makers, which then, of course, have a larger market. So that was the first topic from my side. Thank you. And I will leave to the next presenter.
Yes, thank you.
Or
Magnus.
maybe I shouldn't. Okay, Matt said I keep the control and he can talk. Is that possible?
Yes, because now we will welcome another member from the Swedish Transport Administration who will join Magnus for the next presentation, and that's Mats Mattsson, and he is a project manager for this pilot on sustainable traffic rules. And just so you know, we're a couple minutes behind schedule, so just try and have it about 8 minutes if that's possible. Thank you.
Okay, can you hear me, Christine? Is it working?
Yes.
Yes, good. Thank you. And Mats Mattsson is my name, and I'm project manager for this project. And as we have seen here, that future transport system will need digital traffic routes right now. We can see that new ITS systems and this going out, and we see that the systems in the car, they get wrong information. So we think that the road authorities and the transport is going through a transformation right now, and this will require digital road infrastructure. You can change, Bill. And the Swedish perspective today is that we have about 240,000 traffic regulations today, and it is mandatory today to deliver in PDF A files, dead documents, and we have an XML standard in Sweden, but it's not mandatory to deliver in this standard right now. So we have to move so that it's going to be mandatory in Sweden with changing laws and such things, so we can get there. And it's, as Magnus told us, it's the Swedish Transport Agency, Transportstyrelsen, who is responsible for STFS, that all these regulations is stored. And on the Swedish Transport Administration, Trafikverket, we have the road network, the National Road Database. So two different organizations in Sweden who are responsible for this. Take the next bill, Magnus. And the traffic regulation must improve existing traffic regulation, not fully machine readable. And if you should have as a picture had a car, just that's going to be more automatically. We really need this, and we must improve our ability to create and distribute traffic regulation. And we have put a vision in our project. It's that digital traffic regulation and road signs should always have the same message and geographical location. So this is our goal. Take the next picture, Magnus. I think it's your picture.
Yeah, and now we have a picture of the current process. And okay, yeah, I take it up. We have the like 290 municipals, a couple of regions, and some national authorities which issues the traffic regulation orders and stores it in this national database. And but today we as only or I wouldn't say only, but most things are machine readable, but not always. We have a manual step here where Trafikverket takes in the new traffic regulation order and updates the national road database. So that is something we will look into to develop and make more automated. The new process, we will have automated steps. We will have a module that interprets the traffic regulation order that comes in a machine readable data format, which is called Beata, which is being put into production right now. And then we will establish a new internal database for digital traffic regulation in Trafikverket, which has all the depth and all kinds, which can handle all kinds of traffic regulation orders, as opposed to the existing national road database, which only has a subset. And then, so we have a discrepancy reports, which are created by this quality control module, which Frida will talk about a little bit later. We are also on the way to establish a road sign database, which is used, of course. We will hear more about this later on, so we can compare the traffic regulation order with the actual road signs to make better quality. And then, of course, look into new standards for distribution, like DATEX2, as I mentioned before. And we are also possibly planning a sort of data quality feedback API here. So the tool makers can check their traffic regulations order before they are published. And I talked about interpretation, just a short mention of what this means. We have, at least in Sweden, a concept that different authorities have a different mandate or jurisdiction to issue traffic regulation orders, so they can be layered on top of each other. So for the actual driver, it means that it could be 30 kilometers per hour, but there are 4 or 5 rules on top of each other. So we need to segmentize and split this so we can deliver the actual right speed limits on each location. Okay. Next slide. Some general findings in this project. This feedback loop has proven very useful to find discrepancies. We can find places where we don't have a traffic rule, or we can find places where there are conflicting rules and wrong road sign, or the wrong location for the road sign, etc. And of course, we have also learned the limitations of our national road database as of today. So there are some things we need to work on here in Sweden. The possibility to handle future roads is not supported by all tools, and we don't handle all types of traffic rules. And it's also very complex to change data as today, and we need to make this more quick and streamlined. So that was all from this side.
Yes,
thank you.
Thank you, Magnus and Mats. And you will be able to ask questions to them later in the Q&A session. But now we will move on to the next presentation, which is Johanna Thorn from Universes. And she has been the project manager for the project on AI-powered discrepancy analysis. So please.
Thank you, Kristen. All right, so I'm going to talk a bit about our part from Universes, what we've done in this project. Let's see if I can change. Okay, good. So Universes' core capabilities are have the background within autonomous cars and autonomous vehicles in general. So understanding where you are and your surroundings. And in the case of this project, we've taken the same type of technology, but we've put it in a smartphone. So this is our product called 3D AI City. And this smartphone will then look for different objects in the roadside environment. We get that data, and then we can sort of deliver it with almost real time for the users. And so 3D AI City, it's a way to harvest data very cost effectively. So you don't need any specific vehicles. You can use cars that are already driving around, and you get this data in almost real time. And we're also working with different types of data channels. So in this presentation, I'll focus on one, which is the traffic signs, but we do have more as well. And we work also with GDPR a lot, and we're GDPR compliant. So I mentioned we have a few different data channels, and road quality is one. We're also working with roadworks, but the traffic signs are the focus in this project. So what we wanted to do here was to create a sort of digital twin that we also can maintain. So we've been collecting data throughout the project, and I'll show you sort of the results around that. And our second step that we've also been focusing on is to ensure that we're also the signs are also on the correct location compared to the database. So in building this sign database, we have a lot of technology running in the background, and we're using both the GPS positioning and the fact that we're moving in image space to position these signs. So we're triangulating the signs, and we are also getting a better position than you would if you just put a GPS tracker beside it. So the history and where we started. So we had a first project that we started together with Stockholm Stad and Trafikverket, and the background there was that they had no database connected to where the signs were in reality, and there were also some unclear quality databases that we had from different sources. So we wanted to make sure to have like one consistent database. But that project was quite small in scale, and we started to look at these different things that we could do. And in this project with Gothenburg as well, we've done a bit more, some more additional data collection, and we've looked in a wider area and really tried to understand also this different data sources that you can get these regulations from. But we've been focusing on MVDB from our side. So the collections in Gothenburg, we've had a taxi company that we've been collaborating with. So they've been collecting data throughout the project. And you can see here the numbers are growing quite fast. And these are the unique signs in the inventory. So it could be that we've seen one sign maybe 10 or 20 times during this time as well. And also during the project, we've been adding signs. So we've seen that more types of signs are interesting. We've been adding warning signs and all the prohibitory signs as an example. But we also identified a few additional signs that needs to be added in the future. So other signs that do affect these regulations in different ways. And when we've found the position of the signs, so in this case 260 signs, we do a comparison directly with MVDB. So we can see where the speed limit should change, but where the signs are positioned could differ. And then if it does, we flag them as something that we need to investigate further. So when we look in general at this inventory and matching with MVDB, we can find around 5% mismatches, and this could have different sources why it's mismatching. And we have also some data from other locations to just compare. And something else that we've been focusing on in this project is also how long the mismatch actually is. So is it okay if it differs 10 meters, or is it okay if it differs 20 meters or so on? So that's something we also been looking into and discussing within the project. So some of the identified possible reasons for mismatch, we found signs that are connected to a roadwork, and that gives us a flagging of a mismatch. It could also be that we have some additional signs under the first sign. So in 200 meters, we have a change of speed, for example. It could also be that the signs have been changed, but the regulation hasn't been updated, or the regulation was updated, but the sign hasn't been updated. And the reasons behind that could be many, of course. We have also had some wrong detections that give you this sort of same flagging. And just looking at some examples. So here, I'm not sure if you can see, but the roads in the back are colored based on the speed limit regulation in MVDB. And then these yellow signs here are marked as a mismatch. So on one side here, we have 100 sign, but we have 110 in MVDB. So that's been flagged. On the other side, we can see the regulations change a bit before the signs are coming. There could also be other examples. Here's a 30 street, but it has 50 in NVDB. Or we've also seen a lot of these mismatches on ramps going up on highways and so on. And also, of course, you can find a truck with a traffic sign on, and then you get a mismatch on that. So that's something we've also identified as something we need to look into more. And while we're also doing this, we're also finding signs that are in need of maintenance. It could be that you have stickers or that they're leaning or something else. So that's an additional value that we've also been able to provide in this project. I think I'm done there. Thank you.
Thank you, Johanna, for the great presentation. And you will also be here for the Q&A in a little bit. And now we'll move over to the next presentation. It's also from the Swedish Transport Administration. It's Frida Gudmundsdotter. She will continue talking about the quality aspects on the next presentation. So if you could take over the control, Frida, and talk about data verification.
Yes, thank you. Yes, I will. Okay, yes, just checking this. Yeah, I will talk a little bit more about the data verification. Magnus pointed out in the flow there, we have quality controls, and I will tell you what we have done until now. And I start with this flow for speed limit, and I just make sure that we have only been doing these quality checks for Gothenburg. And if we start with the data and the sources we take into the control, we have on the left side 4 databases. The top one is the traffic rules that we talked about earlier, and the second source is the National Road Database in Sweden, NVDB, and the third data source can be other data that we find useful for the control. In this case, it's city boundary for Gothenburg being used, but we could use something else for other traffic regulations. And the fourth source is the signs from Johanna's company, Universes, we have been using this time. And what we do is that we combine these 4 sources and start to ask questions to the data. And I see if I can point. So the first question is, do we have traffic regulation in place on this street, for example? And if that is yes, we check if it's matching the NVDB speed limit. And if that's okay, then we check if the signs are existing and if they have the same speed limit. And then the data is okay if that's true. If either of these 2 last questions are no, if we have mismatch with NVDB data or the road sign say something else, we take that out and take a look into it in a further analysis. And if we go back to the first question, if we don't have any traffic regulation in place, we only have the NVDB data to look in, and that is something special for Sweden, that within the city boundary, we should have 50 if we don't have other regulations, and 70 outside city boundaries. So if that's the case, and the signs are existing and showing the same speed limit, the data is okay. But if we have other speed limit than 50 inside the city boundary or 70 outside, we will take a look into that and also take the road signs and look into them. And if you have road signs that are different from the base speed limit, we will also look at that as a deviation reports and analyze. And the next slide, we have done similar flow for heavy vehicle restriction and pedestrian area as well in Gothenburg. And we will continue to test this next year on more traffic regulations. And we use FME workbench and will in the future use FME server for automation. And for analysis, we use ArcGIS Pro to see why why we have deviations. And just a few numbers so you understand what we have been looking at. In Gothenburg, we have around 3,300 kilometers of road network, and of that, we have only 16% with traffic regulation, meaning that the rest should have base speed limit. And as well, just to point out how many traffic regulation the municipality has to maintain, it's about 9,000 for all rules then in Gothenburg city that they need to maintain. And we have some numbers here as well, but just take them as a hint because the system is not finished. But at least we find out that 87% in the first run of speed limit was correct, meaning that the NVDB data was the same as traffic regulation. And then we have around 13% that did not match in the first run. And we during this work, we have found some things that we need to fix in the program. So I know that this number will be better next time. But this is what we have today, and we will run it again when the program have filled new data into the databases. Yes, and I just want to show you example then of what we find. I hope you see this some kind of clearly. Here we have different between the traffic signs. They are here 60 and 90, and we have the traffic regulation on the roads, and the split where you should change lies 60 meters away from the signs. This will give us opportunity to analyze if we need to change the traffic rule, or do we want to move the signs, or is it okay that you have 60 meters away? This is something that the regulator, the people who are writing the traffic rules need to look at, and we will have then possibility to correct if needed. The next failure or next thing that we can find is, of course, if you have traffic regulation without any signs. In the reality, this is outside the school. We have 30 going on this street in the traffic regulations, but no signs, and NVDB has 50. In this case, we will look into if the traffic regulation is applicable or if we need to go out and put up a sign. And the last example is failure in NVDB. In the National Road Database, we have, this is area within the city boundary of Gothenburg. And I've just drawn this polygon around area here that has in NVDB 30 kilometers, but there are no signs and no traffic regulations in place. So this will give us opportunity to update NVDB. Yes, and my last slide says a little bit future use of traffic regulations data. Magnus have talked about that before a little bit, but I just want to lift up that this database will give us opportunity to update NVDB more automatically, starting as soon as the program are working. This will also open up a possibility for us to provide municipality with BTR data, meaning the geographical digital readable data for the traffic regulations, so they can do their own quality controls on traffic regulations. And I know the next speaker will talk more about that. And of course, this database traffic regulation data will give Trafikverket possibility to do more quality controls in a bigger scale on NVDB data. And the last point is that this cooperation between the stakeholders we have had in this project has been really learning curve for me at least, and I think all of the others. We learn of each other and we understand each other much better when we work over the boundary of our municipalities in Sweden. So that's my point here.
Thank you, Frida, for the presentation. Great. And now we will move on to the city perspective. We have with us Jonas Malmryd from the city of Gothenburg, and he's been the project manager for the pilot in Gothenburg, but he will also present the findings from Stockholm. So please welcome Jonas.
Thank you, Christine. Yeah, so I'm going to talk a little bit about a city perspective on digital traffic regulation. So first, I will talk a little bit about the importance of digital traffic regulations and some findings from this pilot. I will also give you some examples and then move on to some lessons learned and a little bit about the way forward. So why is digital traffic regulation important? Well, first of all, it's necessary to enable new technical solutions, not least autonomous vehicles, but as someone talked about yesterday, ISA, for example, intelligent speed assistance, is only about 80% correct. So if we can manage to deliver high quality digital traffic regulations, we will probably be able to increase this to maybe even 100%. But it's also useful, as previous speakers have talked about, to enable deviation report, automated deviation report, machine learning and AI within our internal processes. And last but not least, the municipality strives to provide a high service level, and that includes delivering data and information in different formats and different channels where it is desired. And why is the quality important? Well, the more we integrate this type of data, the more crucial the quality gets. So some findings from this project. Well, we can conclude that we do deliver machine-readable traffic regulations, at least according to current standards. And Frida and Johanna's numbers do support this. We have not identified any systematic faults within our process. However, we have discovered numerous human factors that have created or resulted in deviations of different types. But even if we would deliver 100% correct data, there would still be deficiencies for the end user today. And this is because partly due to BTR data, the development of these data since the last couple of years, and I will give you some examples of this. But it's also due to relevant information and traffic regulations not being included in this process today. The same is true for parts of the road network, private roads, for example. So let's look at some examples. And we do, in this picture in the middle, we can see two different roundabouts. And this is in the central parts of Gothenburg, right next to the train station. On the left here, we have Åkareplatsen. And if you look at the blue lines in the picture in the middle, you can see that they do not connect, and they are not really in accordance with the roundabout. This area was reconstructed and a little bus terminal was built, and we built this roundabout. And all traffic regulations here weren't updated. But if you look at the picture to the left, you can see the green lines, and this is from the National Road Database. So the information has been manually corrected, but it's not actually in accordance with what's legally regulated. So it's a deviation here, obviously. Up to the right, you can see another roundabout, and in the zoomed out picture, it looks to be correct. And the legal traffic regulations here are in place, but in the up right, you can see a zoom in on this roundabout, and then you can notice that the lines do not connect. So basically the roundabout is an island on its own. So it's a human factor here where we haven't been detailed enough when connecting the different spots in the network. Even in that case, the National Road Database is updated and correct, and the legal aspect of it is correct, but the data is not sufficient. We have some other examples, and here it's more about the older BTR data. You can see on the left here, it's a cutout from the PDF with the actual traffic regulation, and it states that the black lines here show an area where it's regulated as a pedestrian area. And this is a square called Järntorget in Gothenburg. But if you look at the image to the right here, you can see the BTR data, and it's just a little red spot out in the street next to the square, not even on the square. And this traffic regulation was written back in 2008. And at that time, we were unable to identify or connect an area as BTR data. And we do have some different types of problem with the data quality when it comes to areas. And it can be densely populated areas or emission zones or pedestrian areas. So some lessons learned. Well, to correct all traffic regulations would require extensive resources. And to this, obviously, there's a financial aspect. It might not be so crucial for Gothenburg and Stockholm, bigger municipalities, but we do also have lots of municipalities in Sweden that do not even have the systems implemented or the processes to actually create this BTR data. But for Stockholm and Gothenburg, the bigger challenge here, I think, would be the uncertainties. We do not have long-term guidance or regulation or requirements for this types of data. So to invest in updating the quality of the data when you don't know the long-term requirements, that poses a challenge. During this pilot, we have also realized that we are in a transformation phase, and it's not just about new technical systems or automated vehicles. It's also about the whole question about who and when and where and how we do communicate these traffic regulations. Historically, we have done this, we're communicating to citizens and people, but now we're moving more towards communicating with machines. And this kind of turns the whole table upside down, both as far as technology goes, but also the legal framework for this. In moving forward, we also need a holistic view. As I said, we need to include more sets of traffic information and especially traffic regulation, but also all different types of road network, private roads, for example. The human factor needs to be raised or at least limited. And if you look at the data today, even though we have maybe 95% correct data, it's still not sufficient to let autonomous vehicles run solely based on our traffic data or regulation data. But the way forward, we do have a legacy problem. But if you look at speed regulation, for example, Frida talked about the base speed limit. In Gothenburg right now, we are doing a speed review and aim to lower the base speed to 40 instead of 50. And this obviously includes an inventory of all speed regulation. But this is not a quick fix because the time frame for this project, I think, is about 10 years. So, but it still gives us the opportunity to go through this in detail. During this project, we have also got lots of useful deviation reports, and we will now take a look at that and update all the traffic regulations accordingly. The collaboration and cooperation with relevant authorities has also generated a lot of value, and we see this as necessary to be able to succeed moving forward to combat these challenges. The human factor also, we think, can be limited, and we will have to further develop our decision support systems, and we will continue our dialogue with our system providers to be able to limit this problem. We have also realized the usefulness of collecting road sign data to be able to compare with our digital traffic regulations. And we do not know today exactly how or when we will implement this, but we do look into doing this moving forward. Thank you. That was all for me.
Thank you, Jonas, and hope you have a lot of questions for Jonas and the other speakers in a little bit, because now we have the last presentation before the Q&A, which is we'll welcome back Magnus Gustin from Swedish Transport Administration, but also Jonas Almqvist, who works as head of section for information analysis at the Swedish Transport Administration. Please welcome.
Okay, this is a final slide with some additional conclusions from my side here. I think most things maybe have mentioned already. We need to develop the capability to collect, store, and distribute digital traffic rules. And this includes all types. I'm thinking of the dynamic side mostly, which is not covered today. And we need to support different location referencing types as well. And we need to improve the data channels. We need to continue to support and enhance the existing national road database, but we will also we must start using DATEX 2 in its full implementation of the traffic regulation package. And of course, as mentioned, we will need to develop digital collaboration around the content and data quality, like data quality loop, and further develop different web services and tools around this to make all actors, all municipalities, etc., able to participate in this flow, as Jonas said. And we will also need to address the thing about future roads, so we can be ahead of time when we start writing digital traffic regulation orders. Just some short conclusions, and then I will leave over to Jonas Almqvist.
Thank you, Magnus. So I would like to highlight 3 things as next steps as we move towards digital traffic regulation. So we heard both Johanna and Frida mention the value that the road sign database brings when it comes to quality assurance. And I would also like to add that from a user experience, we want to see that one-to-one relationship. Imagine that you're in your car and your navigation system has a stretch as 30, but the camera in the car detects a 40 sign. That doesn't give a good impression of data quality. So we are looking into creating a database for road signs. We're using in-house data, 360 imagery of speed limits, and see what we can achieve with that, together with an analysis of internal needs at the Swedish Transport Administration. What would a road sign database, what requirements do we see internally? And then in 2024, we will combine these two. What did the POC, the proof of concept, bring, and what did the survey bring? And see what is the best way forward according to needs and what we can achieve with our own data. Secondly, on the 30th of November, our Director Generals of the 2 organizations, Swedish Transport Administration and Swedish Transport Agency, will meet. And one of the things that they will discuss is declaration of cooperation between the 2 of us. And I really see high value in this because cooperation is key to bringing this forward. And finally, we are awaiting a government mandate to proceed with a preliminary inquiry on changing or making amendment of the regulation. And we should be seeing that sort of now. We'll see what happens there. But I think it's also in that work, it's also important to keep in mind those challenges that Jonas reported from the municipalities' point of view with the cost, etc. So those will be included in that work. That's all I had. Thank you very much.
Thank you, Jonas and Magnus. And now it's time for the Q&A. And I'll move to the next slide here. Alva, could you please open up the chat, but also the ability to turn on audio and video for the participants? In the Q&A, you could either write your question in the chat, and please then write who you're addressing your question to. And you can also raise your hand. And I see that Petter has raised your hand. If you're able to be unmuted here by Alva.
Yes, thank you. All right, there was already a long question before, but so I had a question regarding the first, let's see now, share my, the first presentations. I was curious about the part where the machine readable data for traffic regulations. What can you elaborate on the formats for this data? Is there an unambiguous way to express traffic regulations such as solid white lines or give right-of-way rules and that kind? Do we have any standardized data format for this? And are they easy to express in a way like Vienna Convention on Traffic Regulations and so on?
Okay, who will answer this? Maybe I can begin at least. We haven't really dived into all aspects of the standard. As we said, we have this so-called standard in Sweden, which is an XML-based standard called BTR, which has been developed during the last 10-15 years. I cannot answer if it covers all the aspects of our new requirements. And we, in this pilot, we have basically more investigated the flow and focused on some traffic rules like speed limit, heavy vehicle restrictions, pedestrian areas, and so on. So we have not looked into all kinds of rules.
Okay, so there is no one-to-one translation of what is written in the legislation or traffic regulation to a data format with a data model with expressions that you can understand. There is no such thing in place.
No, well, it is one-to-one, but what I was answering was we haven't covered all cases. We have no complete gap analysis about how good the standard is, really. But
so there is a standard in place somehow.
Yeah, of course. Yeah, there is a standard.
Okay, thank you.
Thank you, Petter. And then I see in the chat we have some questions for Magnus and Mats. The first one is, can you elaborate on the functionality of Beata? How does it transfer the traffic laws written for humans to interpret to a machine-readable format? For example, how do you break down the responsibilities for right-of-way situations? Do you have some standardized structure for this?
The purpose of Beata is not to create machine-readable data from free text, as you might think. The issue here is more put together all different machine-readable traffic regulation and make this segmentation. So we need. I showed briefly a picture about the speed limit with different layers. That's really the purpose of Beata. So I don't know if you thought about translating free text to machine readable. That's not the case.
I can just add to that the data in STFS, the first database that Beata reads, has this information, and that's when you are providing the traffic regulation, you provide the PDF as usual, but some or many municipalities also provide digital data, and that includes who it's applicable for, when it is applicable. There's a lot of information added there, and that's the data Beata use for understanding which speed limit is applicable for which part of the road, kind of. That's maybe a little bit answer to the first one. And if you want to have more technical view into this, you can contact me and we will help with that. It's really technical, so it's a little bit hard to describe here, maybe.
Thank you, Frida and Magnus. And there's another question also for Magnus and Mats. Have you considered vehicle type specific regulation? For example, how can the system provide right information for heavy trucks? For example, speed limits might be higher than the structural speed limit of the vehicle.
Well, yes, we within the DATEX2 traffic regulation standard, there is a lot of ways to express different conditions, like vehicle type and so on. And we basically say there is a standard, and we will look into it and start using it. I don't think we have used it so much already in Sweden, but it's there, I think. So I don't know what else to say.
Yes, we can say, but that in the future, when they get the full database, this TNE HR database, then we have all the regulations in a database. But now we really need to get the law changes so all the authorities can deliver machine readable. Before it's hard for us to get a complete database of this. So I think this is a little bit in the future, but the goal is that we could do it, that we have the fully depth of the traffic regulation in one database.
Thank you. And I don't see any other questions in the chat or any raised hands, so please write your questions if you have any. I do have a question while we're waiting for everyone else to write theirs. It's for Jonas Almqvist. Are there any regulations we should start with that's important to begin on this journey of getting machine readable traffic rules for the whole network?
Yeah, I imagine that if and hopefully that when we get this kind of amendment to the current legislation, that we will start in increments. Start with the most high profile type of regulation, which I would say is speed limit, working on that and then continue in increments with other types of traffic related data that is also signposted. There we might see the biggest value in the beginning.
Thank you, Jonas. And I also see in the chat from Ville here, basically what I was trying to point out is the hierarchy of the rules. If you have considered how those should be applied and how should the system be designed. So follow up to Magnus and Mats there.
Okay, the hierarchy, as of today, it's implemented in a rule, sort of rule database or data, which is in this program. I don't know. There is ways to say which law section is higher than the other in Sweden. So that is basically expressed in digital rules in this system as of today. I don't know, still know if this is the answer.
Otherwise, you can always contact them afterwards as well.
Yeah. Yes, it's right. We have in Sweden, all this, the BTR and HR standard is only developed from Transportstyrelsen for many years ago. So we have just used this, and it's well documented, and it is on the Transportstyrelsen's website. You can download it as well, and it can upgrades on the data catalog almost every year. I think it says catalog is up in number 33 now. So there is an XML standard.
Thank you, Mats. And I don't see any more questions. I'll do another one, and it's to Jonas Malmryd from Gothenburg. You worked on this topic for quite a bit now in NordicWay, but do you have any other advice to other municipalities who want to go on a similar journey as you have? Where should you start?
Well, try not to do it on your own. Try to cooperate with at least on a national level, I think, because this is a challenge that to be fruitful, we need to implement the big scale, and this is the problem that I talked about a little bit in my presentation, is like the problem with gaps with private roads, for example. I mean, if the end goal is to reach autonomous vehicles, then we can't have black spots within the system. So, I mean, you need a cooperation with all relevant authorities for the results to be fruitful, basically. So don't do it on your own. Obviously, you can start to investigate internally, like what are your, like, make gap analysis or whatever. But as far as implementation goes, I think cooperation is the key.
Yes, that's a good advice. Thank you, Jonas. I think now we'll move on to the next. Oh, now there's a question here. Martin Johansson. Alva, you can allow him to unmute there.
Okay, thanks. I hope the mic is working now. Greetings from Finland. The session started with a meter presentation, and then I didn't see much of meter in the national projects or pilots that you were doing. How do you see this meter now in a, let's say, short-term or long-term perspective? How would it affect your national work, and what are your plans? Can you say anything about that yet? Thanks.
I don't know if I should answer or you Jonas. Short one
can share.
Short one from me. This meter topic is just a small part of our project. We have been looking into the meter standard to basically benchmark ourselves and to learn what capabilities do we need, what information do we need, do we cover all the actors and flows. So I guess the next step would be really to take this analysis and this report and maybe create some activities for the future.
Yeah, and I may add that, I mean, we see a great value in making the digitalization as close to the source as possible, meaning the legislator should do the addition of this BTR component to the legislation. We believe that brings the most value, and we don't see that our current work is in conflict with Meter. I think that making things digital is something that will be beneficial, and that we would be able to deliver in the future Meter format. So we think that there is no conflict in what we are doing now.
Thank you for your answers, and I hope that was the answer to your question as well.
Yeah, thanks. And we'll talk to you later also on this topic, I guess.
Sounds good.
Perfect. And now we will end this part on digital traffic regulation and move on to two more presentations that we have. The first one is from Johan Östling at RISE, and he is the project manager for in-vehicle signage of MCS signs. So please welcome Johan.
Thank you very much. Okay, I have had the pleasure to be project manager for this proof of concept regarding in-vehicle signage and motorway control systems together with some really nice partners, and all of them are in the meeting right now, so I really feel the support from all of them, so that is good. So this is a presentation. I hope you can see the screen and you can read me, follow me, okay? Thank you.
Yes.
Yes. So we have had the IT4PT organization is a public transport organization that is cooperation with all stakeholders in that business. Monoch, known as the interchange operator in NordicWay 3. We have RISE, we have Volvo Cars, Scania Trucks, Swarco doing the signs, mostly traffic signals, etc. And Trafikverket, and in the start of the project we have Volvo buses as well, but they didn't fulfill. But at least they are part of the POC. So I will talk about the POC project setup, our experiences, and some ideas about the next step. So we had managed to get the IVS working, and we have data from Trafikverket from most of the signs that are situated in the Stockholm area and in Gothenburg area. The operating systems from Trafikverket are in different software versions, so that is not the same. But in the end of the day, the great team I have had, they managed to merge the data, and we have the data flow from the API to the interchange, etc., etc. So that was great job done. Unfortunately, we get the data quite late in the project, so we were in a big hurry. So we have not yet fulfilled everything in detail. So I have said later on in the presentation, you will see that we have not concluded perfectly, but good enough, I can say. And we have playing with the IVS traffic sign and a little bit with the IVS free text, and we have talked about how to use probe vehicle data in the project. We think that, and we hope that if we have a data exchange from the vehicle to the MCS system, there is a good idea how to improve the output from the MCS system, that also the vehicle could be a probe and gathering data to the MCS system, making very much better prediction, etc., etc. So it's a good idea and example where the vehicle improves the system. And what were the experience? Yes, one is that we have a national coverage directly. The digital infrastructure is in place already, because all MCS systems that are installed in Trafikverket in Sweden are directly connected to the network, meaning that they are available instantly. So that is great. And the update of the software that is ongoing makes it even smoother. So now we also add the new Nya Länken and the Förbifart Stockholm, etc. So yeah, we are really positive in this. Mostly we are zeros compliant. In the test we have using DATEX2, but ETSI, it's the goal. And there is plan in Trafikverket when to convert, so to speak, from DATEX to ETSI. ETSI is more convenient, it's a European standard, and it's designed for use in car to car and from the infrastructure to the car. DATEX is more designed for other tasks, but in this case, for a POC, it was good enough, so to speak. Latency we saw need to be improved. I have one slide from that. But we saw that there are good ideas how to make it better. And as I said, this is ready to continue. It's up and running, and we hope that the interchange and the infrastructure will continue to run after 1st of January next year. We expect a user acceptance from this system. We think that we have a smoother traffic. It's less speed variation, and also from that we make it more greener traffic as well. I want to emphasize that this system, when we have the information from the sign into the car, is also meaning that that is an enabler for virtual signs. It's also an enabler for autonomous driving. And I think the first one about enabler for virtual signs, meaning that we don't need to construct portals in the road segments anymore, because we have the signs already in the dashboard in the cars. You don't need any infrastructure hardware. And from that we can save a lot of money. And we also could make instant from the traffic management central. They could easily click on a map and install, so to speak, signs where they are sending messages to the cars and to the robotic cars in the future. Here about the latency. This is just a print screen from the measurement. We count when it starts out in the street and when it comes to the car. And as you can see, it's a very different time, and we have not had time to look into the detail why is that say high variance of time. But the best was 19 seconds, and 19 seconds the car could run quite long in 19 seconds, meaning that it must be correlation between the sign and the car, and with this setup, sometimes it works and sometimes not. But this is just a finding. Here is one example from one of the partners in the project, how we could have the HMI in the car. So this is just one example that is moved into the car. And of course, when it comes to the robotic car, it's also important, where are the car, what lane is the car running, should it be in the left or mid line or whatsoever. But this is a good example. And the next step is that today you can see we have just the portals with the signs above our heads when we run the car. And to the right, tomorrow we have the virtual IVS signs, no portals needed, and the dashboard is just electronic or digital. Really cost efficient. Questions?
Thank you, Johan. I don't see any questions in the chat quite yet, but please write them. There we got one from Martin. How to handle legal cars? Not sure if it's a typo or...
You mean that old cars? Okay, of course, there could be an app in a mobile, of course. So the dashboard, everybody, that is also a finding from NordicWay 1, 2, and 3, that the authorities, they are really eager to construct the HMI for the driver. But I think that is a question for the OEM, how to construct an HMI for them. So I leave it to that. Maybe we have anyone that want to comment that from my team, please feel free. But I think an app could be one way to solve old cars, Martin.
Thank you, Johan. And I don't see any raised hands from your team either. I was just wondering, when do we think this is reality? Because in the last slide you said this is what it looks like today and this is tomorrow. When can this tomorrow be?
As we said, it is up and running, and when we have arranged some testing about the latency and do that correction, it could be working in, I just guess now, 6 months, 12 months, in an app, of course. Maybe if it could be in a Volvo car or in a truck from Scania as well, but it's not that far away. But it's also built on that the interchange or similar function from Trafikverket is up and running, of course. Otherwise, it should be quite tricky.
Yes, thank you, Johan. And I think it's time to move on to our last presentation now, which is from Gustav Rönne, who works at Digital Twin. And he has been the project manager for the pilot warning for approaching trains. And Gustav, please go ahead.
Yes, thank you. I gather you can hear me, Christina. Yes, you're nodding your head. Great. You can skip slide to the next slide. As stated in the title, the sub-project within NordicWay 3 is warning of approaching trains. And what do we mean by that? Well, we aim to, in the NordicWay 3 project, test at least parts of supporting safe passage for travelers over unattended level crossings. And an unattended level crossing is a level crossing between the road and the railroad that doesn't have any physical barriers or any semaphore warnings, for example. And there are quite a lot of these type of warnings, or sorry, these type of crossings in Europe and in Sweden. In Sweden, there are approximately 3,500 of them. They are being converted to attended level crossings, but it takes a lot of time and a lot of money. So in the foreseeable future, there will be a lot of unattended level crossings still operating in both Sweden and the rest of Europe. So that's the background. The idea or the solution is that travelers are warned when they are approaching an unattended level crossing and a train also is approaching. And that is made possible via correlating the GNSS or GPS position of the trains and correlating that with the location of all the unattended level crossings. And the last step is also correlating that with the actual traveler, for example, a car traveler. So with these three information instances, we can provide a warning. In NordicWay 3, we use a then message to achieve this. And what we have tested is publishing this information in the NordicWay 3 interchange hub and also consuming it. And the idea is that the consummation or the parties that can consume it are everybody, for example, a car traveler in the car navigation system. The plan is to go ahead in Sweden and make full-scale implementation and later, hopefully, also Scandinavia and Europe. But in order to detail the solution a little bit better, I like to show you a little film, and if the film doesn't work, then the Q&A session starts. But if you can skip to the next slide and try to open the film.
Yeah, now here I think we need some help from Alva, so she can share it with audio. Are you able to help us with that, Alva?
I don't know. Maybe if you try to. It worked yesterday with the video.
All right, so that was a broader view of the solution, and just to be very specific, in NordicWay 3, the solution we tested was mainly related to the interchange node and see how we could provide that information and also consume that information. All right, questions, thoughts?
Yes, please write your question in the chat or raise your hands. While we wait, I'll start with one question then. So in this pilot, you work with combining information from several types of transport. Could you reflect a bit on how the value of combining data from several transport modes for digital services?
Yes, exactly. It's a good question. What we've seen is that there are quite a lot of information related to road users. That's our interpretation anyhow. But when it comes to multimodal transportation, there's not that much information between the different types of transportation, for example, rail and road. And what we see is that, I mean, the travel, a package, for example, that you order, the different modes of transportation, or all normally encompass both road, rail, perhaps flight, perhaps other means of transportation. So what we see there, there's a huge benefit of combining the information across the different modes of transportation. And there's a need, and there's also a lot to do there. That's one explanation anyhow.
Thank you. And now we got some questions in the chat as well. First one is from Björn. What will show in the app if there's no contact with the network, or if a train doesn't send a signal? I'm thinking that people that doesn't get a warning will not look out as much.
That's a very good question, and that touches upon one of the main, I would say, perspectives of this solution. And on the other hand, you can view this information, warning of approaching trains, as information. Information that now beware, a train is approaching. On the other hand, another perspective is saying that this is safety-related information, not only pure information. And if you look at the train side, they have a history of course working with safety-related information. Two trains cannot occupy the same track and travel against each other. So either you look at this information as safety related, and then you have to be extremely sure that the app is working and that all the trains are equipped with GPS positioning, and that the information that is provided is accurate. You also have to make sure that the traveler actually uses the app. So there's a lot of perspectives here that you need to take in account. On the other hand, if you only view it as information, then you could say that, well, there are already today 3,500 unattended level crossings that have no information whatsoever related to whether a train is approaching or not. And then you can say that, well, some information is better than no information. That also correlates to what the C-road standards support. And I've been in contact or have had discussion with Johan Schollers related to the C-road standard. And currently they're working or trying to encompass this use case with unattended level crossings in a more formal way that says that you get information, but it's still up to you, dear car traveler, to actually cross the unattended level crossing in a safe way. So just to be perfectly clear, we have not provided an app for the general public as of right now, and there will be quite a lot of time, I think, before we do that. But what we do is aiming towards full-scale tests on secluded areas of the railroad where we know all the trains have real-time positioning. And as you stated, related to the app, actually test the behavior of the Well, I just got the call that's disturbed me. Sorry for that. Where was I? Well, yes, full-scale test where you test the behavior of the traveler and test this all these different aspects of how to use warning of approach.
Thank you, Gustav. I think we have time for one last question. Has this alert about an approaching train to pedestrian been analyzed from the perspective that it will distract the pedestrian's attention? And the person will continue walking while opening the phone and walk to the crossing without noticing the train and not stop to see the phone as it happens on the video?
Sorry, could you repeat the question again? I got the call and then I didn't hear what you said, Christina.
Yes, it's also in the chat, but the question was about behavior again. If you studied the perspective that the pedestrian will be distracted when it looks at their phone and continues walking if they don't stop, just so in case they don't walk into the crossing while they're distracted.
Exactly, and that's part of all the behavior aspects of using this in a mobile phone, for example, that needs to be tested further. I think that the use case related to car navigation systems are a little bit more straightforward. There you can provide information and the car user is perhaps more used to and it is more suited for these types of warnings. So I think that there's still some things that needs to be detailed relating using this as an app for a private citizen, but using this in the car navigation system, I think it's nearer in the future, but still not fully implementable, I would say, today. The technology is there. That's not the problem. It's the behavioral aspects. How will a car driver, how will a pedestrian react when getting this warning?
Thank you, Gustav. And now the time is up for this webinar. And I do want to thank all the presenters, but also all the participants who've been active in this webinar. And the program will continue after lunch, so hope to see you there as well. Thank you, everyone.
Thank you.